Hey there, boys and girls. Mr. McCauley here. Here's a little video about things you need to know for your fraction test. Fractions, our friend fractions. There's often a definition we start off with. Today we're going to define the numerator, which is a number on top, but what does it represent? It represents how many pieces you're talking about. The denominator is on the bottom. It represents what the whole thing is divided up into. Numerator on the top, denominator on the bottom. On the test, there might be some questions where you might have to represent some fractions. There could be some shapes, and you're going to do that. So in this shape, the denominator is 8. So you got to divide it up into 8 pieces, and then you're going to color in the pieces you need. It's 5/8, so you're coloring in 5/8. In this next circle that you can't see, sorry, it's already divided up into 5. So you're just coloring the pieces that you need. And this one, it is 2/3. So the thirds means you got to divide that up into 3 pieces and then color into, not the best coloring job. Okay, so now let's look at the bottom of that page. Sometimes you might have to put fractions in order. And if the denominator on the bottom is the same, which means the pieces are the same, for example, a pizza divided up into 11 pieces in this example here, all you need to do is to organize the numbers based on the numerator. So 2 out of 11 is the smallest, going up to 9 out of 11 really is the biggest. However, if you have the same number on top, it's kind of the opposite. You start organizing by the denominator, but a big denominator really means a small amount. If your mom has a pizza and you get 3 pieces, but it's cut out of 12 pieces, that's not a lot. But if you get 3 out of 3, well, that's actually the whole pizza. Now let's talk about improper fractions. That's when the numerator is actually greater or equal to the denominator. And a mixed number is when you have a whole number plus a fraction. You need to be able to go back and forth between the two. 3/2 is really 3 halves. So you put those 2 halves together, you get 1/2. You get 1 whole, and 1/2 left over. So you kind of divide the 2 into the 3, and you tell me what the leftover is. 3 goes into 4 one time with 1/3 left over. 5 goes into 12 2 times with 2/5 left over. Now you need to be able to go the other way too. 1 and 1/2 is a mixed number. So that 1 is really 2 halves, or 2/2, plus the 1/2 is 3/2 altogether. Whoops, not 4, 2. Sorry, dudes. And this next one is out of 4. So you got 2 wholes. So that's 4 out of 4 and 4 out of 4 plus 3 out of 4. And you add those all together, you're going to end up with 11 out of 4. So 2 is really 4 out of 4 plus 4 out of 4 plus the 3 out of 4. You add those all up and you'll see 4 is 8, and 3 is 11. So it's really 11 out of 4. A fast way to do this is really take the whole number and multiply it by the bottom, and then add the top. So 1 times 9 is 9, plus the 7 ends up with 16. So it's 16/9. Let's go to another page. Okay, in this page, we're talking about organizing fractions on a number line. Here's some of the important fractions you may want to be able to work with. Also, sometimes 1/3 gets popped in there as well. Now, in our lesson, we use licorice as a number line before, but in this case, I've drawn the licorice as 20 centimeters. So really you can think about 0 on one side and 20 centimeters over there. Let's look at 1/2. Where would 1/2 be along here? Well, if it's 20 centimeters, then with your ruler at a 10 centimeter mark, I'm just guesstimating here, that is where the 1/2 would go. Now let's talk about a quarter. Again, if it's 20 centimeters, a quarter you divide 20 by 4, and the answer is 5. So 1/4 is 5 centimeters in, and again, with a ruler, you'll be able to figure that out. There's 5 centimeters, and so there is 1/4. Now 1/5 is 20 divided by 5 parts. That means one part is 4 centimeters. So 5 centimeters there, 4 centimeters would be about here, and that means that 1/5 on the number line, 1/5 of the licorice would be about there. 1/10, again, we can go, if its whole thing is 20 centimeters, 1/10, 20 divided by 10 is 2, so at 2 centimeters would be where 1/10 is. 3/5, well, you already know where 1/5 is. It's at the 4 centimeter mark. So 3/5 would be 8, 12. At the 12 centimeter mark is where 3/5 would be. So that's just a way of using the numbers, the fractions on a number line. I'll usually let you know how big the number line is to kind of figure that out. Here I'm doing where 3/4 would be. 8/10, well, you know where 1/10 is, so you multiply that by 8. That gives you 16 centimeters is where 8/10, somewhere in there. It's getting a little crowded right now. And 4 out of 4, it's really just 1. So that would be right at the very end is where 4 out of 4. So you're asked to organize them on a line. This is a strategy you use. Here's the same idea. This time it's a number line, but the number line is out of 12 centimeters. Now you'll notice that all the numbers I picked here, they're all kind of factors of 12. 6 goes into 12, 4, 3, all go into 12. So that's kind of how you set that up. Again, the halfway mark will be where 6 centimeters is. And at 3 centimeters is where you'd end up with the 1/4. So let's take a look at this. The 12 centimeters divided by 6 is 2. So 1/6 would be at the 2 centimeter mark. This is just a way of accurately putting fractions on a number line. 12 divided by 4 is 3. So at the 3 centimeter mark, that's where 1/4 would be. Let's cross those out. 1/3, 12 divided by 3 is going to be 4. So at the 4 centimeter mark, that's where 1/3 would be. And so on and so on. One interesting one is 7/6. 7/6 is really 6/6, a whole, plus 1/6. It's an improper fraction. So the 1/6 is really 1. And then we have 1/6, which is, so 6/6 is 12 centimeters. And then 2 more centimeters for the 1/6. So 7/6 would be right about there. Now let's take a look at these fractions. We did some fractions with hexagon pattern blocks. One full hexagon is a whole. I'm sorry, it's a little bit off of the screen. But one whole hexagon is a whole. And the triangles, 6 will fit on there. So that would be 1/6. 2 shapes here fit on the hexagon. So that is 1/2 or a half. And 3 shapes here fit on the hexagon. So that's really 1/3. In this example here, you're looking at a whole, so that's 6/6. Sorry, you can't see it. Another 6 out of 6. And then we have, I think, 2/6. So 6/6 and 6/6 are both 1s. And then you have 2/6. So it really ends up being 2 full and then 2/6. Now, equivalent fractions is our next topic. Equivalent fractions are fractions that have the same amount, but they kind of look different. They use different numbers. So the classic would be 1/2. I'm sorry, you can't see that. But of course, 1/2 equals, for example, 2/4. So they're the same amount, but they're using different numbers. But I could keep going. And it also, 3/6 is the same as a half. So what are the strategies to, let's start off with maybe another fraction. Here is a fraction, 5/15. You could also, instead of multiplying, you could also divide. Let's divide both by 5. So we divide the top by 5, you would end up with 1. Divide the bottom is 1/3. So you can also do equivalent fractions that way. So these are strategies The easiest one is just double it, but you can also triple it, quadruple it, etc., etc. And you can also do some division as well. You could sometimes divide by 2 or 3 or 4 or whatever. Just depends on what the number is. Now let's try to do some equivalent fractions. As we said before, 1/2 is an easy one. Let's just multiply both by 3. We got 3/6, and let's multiply 1/2 by 5. You can get 5/10. 5/6. Let's double this time. 5 times 5. Sorry, 5 times 2 is 10, and double 6 gets 12. And let's double the double, so that means 20 and 24. Now let's do 1/3. What are we going to do with that this time? Let's see. Let's do it multiplied by 3. So we get 3/9. And what should we do next? What am I going to do? How about we try to add 1 to the top and the bottom? Adding does not work when you're making equivalent fractions. You cannot add. You can only multiply and divide to give an equivalent fraction. If you add or subtract, you will be making a boo-boo. Don't do it. Let's try a few more. 1/4 double makes 2/8. And let's see, what am I going to do next? Let's try double the double, and you get 4/6. You get the idea. Now, converting fractions to decimals. Now, when a decimal is, let's for example, 0 point something, that something there, that spot is the tenths. Tenths, that kind of sounds like a fraction. And the next spot is the hundredths. Oh, with a TH, sorry. That also sounds like a fraction. So tenths is like something over 10, and hundredth is something over 100. So let's look at these little diagrams here. We have 3/10. So it's 3/10. So that means that equals 0.3 decimal. Now here we have 8/10. So that means it would be 0.8 for a decimal. Let's turn it over to the other side. Grade 4s might need to know this as well. This time we have the squares are out of 100. If I count by 10, I'll find out that I have actually 70 filled in, 70/100. So that means if I'm doing my fraction, 70 out of 100, 70. So 0.70 is the answer for that one. Hey, what if I just had 4 colored in? What if 4 were there? This is a classic one that you might make a boo-boo on. Really, we have 4 out of 100. So you might want to do this. You might want to do 0.4, but that is not right because that's 4/10. 4 out of 10. We really have 4 out of 100, so that is really instead 0.04. Don't be fooled by that one. Now let's go back to this one. This is really 10 out of 10. That is 10 out of 10. And this is now 8 out of 10. So 10 out of 10 is a solid 1, another solid 1, and then we have 8 out of 10. Let's put all that together. We have a big 2 for the 2 holes, and then we have 8 out of 10, 2 and 8/10. So that would look like this, 2.8. You got it. There you go. Last part, this is just for the grade 5s. Grade 4s, you're done. You're done. So this is the grade 5s only. We're going to turn these fractions into decimals. Now, these fractions have denominators that are not 10 or 100, but that's what you need to watch out for. Fraction goes there, so we're trying to change the fraction into a decimal, and the step in between is where we make it out of a 10, or maybe make the fraction out of 100, and that will give us the way to make our decimal. The big challenge is really figuring out, do I want to change this fraction into something over 10 or something over 100? Well, 1/2, I can change the half, the denominator 2, into a 10 kind of easily. So I'm just going to go to change it into a 10. Now to do that, I'm going to have to multiply it by 5. So that means I multiply the top by 5 as well, and I get 5/10. Hey, something over 10, 5 over 10, that's easy to make a fraction. That's 0.5. Now this time 3, next one, 3/5. Again, the 5 can be turned into a 10 pretty easily if I just multiply the denominator by 2. And because I'm doing it there, I'm going to do the multiplied by 2 on top. And that gives me really 6 over 10. Boom, again, 0.6. Now, 3/4, a little bit tougher. A little bit tougher. This is like, you're playing Fortnite for the first time and you don't know where to drop 3 over 4. Because the 4, you cannot change the 4 into a 10 by multiplying it by a whole number, but you can get it to 100 if you multiply it by 25. So 4 times 25 will give me 100. 3 times 25 will be 75. Sorry, that's a little hard to see, but that's 75 over 100, and that is 0.75. Again, 6 and 25. Hey, it's already 6 over 25, so I'm not really going to make it into a 10. I'm going to probably have to go to 100 again this time on the denominator. So 25 times 4 will give me my 100 on the bottom. So 6 times 4 will give me 24. 24 over 100 is 0.24. And you get the idea. Hey, so that's it. Thumbs up. Now remember, this is a good review, but there's still a lot of stuff in there. See you later. If you are looking for some more stuff to do, I always take questions out of the problem bank and the review question, the review part, and the skills bank, and all that stuff. So some questions will ask you to take this information you've heard today and apply it. Good luck, boys and girls, and I will see you tomorrow.